One way of determining this is to analyze the game in a theoretical sense. That is, to see if we can determine whether we will win or lose more often without actually playing the game. To do so, we start with the marker on the start square and think about what will happen when we toss the coin. Of course, we'll either get a tail or a head. If we get a head, we move forward one space and lose. If, however, we get a tail, we move forward two spaces and we stay in the game. This brings us to determining the likelihood of getting a head and the likelihood of getting a tail when we toss a coin. Let's start by going back to our definition of likelihood. We said that the likelihood of a particular event is equal to the ratio of the number of ways in which the event can happen to the number of equally likely possible outcomes. Now, when it comes to tossing a coin, there are only two possible outcomes, and they're equally likely. What are they? A head and a tail. This means that the likelihood or probability of a head is equal to 1 to 2. Why? Because there is only one head of the coin and there are two different possible outcomes. Similarly, the likelihood or probability of getting a tail is also equal to 1:2, or a half. Now, from this, it follows that the likelihood of a head is equal to the likelihood of a tail. And so if we tossed a coin a very large number of times, we would expect to get as many heads as we get tails. Now, of course, what I've just done there is really quite intuitive. But what does it mean in the context of our game? In the context of our game, it means that if we were to play the game a very large number of times, then one half of those times we'd get a head on our first toss and we would lose the game. And the other half of those very large number of games, we'd get a tail, get two moves and stay in the game. Now the question is, what happens if we don't lose on the first move? Of course, we're on this block, and now we toss the coin again. Half of those tosses will result in heads, and the other half will result in tails. When we get a tail, we move two spaces and end up in that block, but following the arrows, end up where we started. For those tosses where we get a head, we move forward to that block and follow the arrows up to this block. What I hope is quite obvious from the illustration is that no matter what coins you toss, you will end up on the block where our marker is now. What should be obvious is that you were unable to land on that square and win the game. In summary, if you don't lose the game on your first toss, you will end up on that square in the top corner. And now I want you to think about what happens next. Let's see what the students have to say at this point.
Okay, Arnott, we're a little confused here. It appears as though we lose the game at the first toss, and then the second toss we're losing as well. I mean, what's going on here?
Are we right to say the game favors losing?
Yeah, are we?
I think you've pretty much got it. Let me show you what I mean. What we've established is that having survived the first toss of the coin, we next effectively land on this square. Once again, we now expect half of the tosses of the coin to result in a head and half of the tosses to result in a tail. If I get a head, I move forward one and win the game. So I have an expectation that I will win half of the games from that position. However, if I toss and get a tail, I move forward 2 blocks and lose the game. In other words, the other half of the tosses from this position result in a loss of the game. Having survived the first toss of the coin, we now win half of the remaining games. Do you notice that in effect we're winning 1/4 of the games that we play? Let me show you. Let me try to summarize what we've observed. We said when you start playing the game, you're either going to get heads or tails. You'll get heads 1/2 of the time and tails the other half. Now, if you get a head, then you move forward 1 block and you lose the game. So all of those games result in losing. Now, should you survive, that is, you move to there and effectively move up to there, you will now either get a head or a tail. A head will result in you winning, and a tail will result in you losing. Now, let's put some numbers to that. We said that 1/2 of the games would result in a head, and 1/2 of the initial tosses would result in a tail. So at this stage, we've lost 1/2 of all the games. Now, of these half, or of this half, that is the games where we've survived the first move, we will get half the number of heads and half the number of tails. That is 1/2 of a half of all the games we play, 1/4, and 1/2 of that half will result in losses. Also, 1/4 of all the games we play. 1/2 plus 1/4 plus 1/4 gives me 1. We will win only 1/4 of all the games that we play. Does that now mean that I will win exactly 1 out of every 4 games that I play? Not at all. I could play 6 games and win all of those games and not be surprised. Our theoretical analysis of that game, our prediction of the number of wins and losses, only tells us that if I play the game a very, very large number of times, then I expect the ratio of wins to losses to be 1:3. Or, phrased differently, I expect to win 1/4 of all of the games that I play. It's time for you to check your understanding of what I've just said. I hope you've enjoyed seeing how we can use our knowledge of probability to analyze a game. The decision to play the game or not is now yours to take. Till next time.
Oh, okay, so that's what you mean. Oh no, you're always the man. Well, it's time for us to go, right?
Yeah.
Well, guys, we'll see you next time. Bye.
Bye.